Today we will continue on this kind of workshop sessions where we will try to make you familiarize with Python and all this kind of libraries that we are using for AI. But before that, I will spend some time to introduce for people that they're not very familiar with some notions of deep learning and medical imaging, which is actually our main research topics. Please ask me questions, and let's make this a little bit less boring for you and for me. So please interact with me during the session. Before we start, we met yesterday, but this is actually my main milestones with respect to my academic career. Currently, I am an assistant professor at Vakalopoulou together with Sterios, and we are working on machine learning topics applied on computer vision and medical imaging and remote sensing applications. And as Olga also mentioned yesterday, we are from University Paris, which is actually a huge university that contains different kinds of disciplines like pharmaceutical universities, medical universities, and as well engineers. So Central Supelec is the call of this university, and it is an engineering school. And our lab is actually called MIX, and it focuses on applied mathematics and computer science. So it has three different disciplines. One that works on quantitative finance, the second one that does more computer science, and the third one, which me and Sterios we are belonging to, which works on mathematical modeling for biological systems. And in this team, which is actually the biomathematics team, we are working on computational biology, on medical image analysis, on applied mathematics, and in general, everything that has to do with life science. Also, except University Paris-Saclay, we are also affiliated with Christodoulidis, the new AI center that started optimized for you. So you don't really need to decide about the architecture or the parameters that you will use. You will just give to the framework your database, and then with respect to this database, you will be able to find the best structure that is based on UNet and give you the best performance. And indeed, they did a lot of experiments and they participated in a lot of things. For example, also BRATS, the data that we are using, and using very, very small modification and this kind of automatic optimization of the parameters, they were able to actually be in the first place. So, and now I know it's time for the break, but before we go for the break, I would like maybe to conclude this presentation in order to have some time to set up for the lab. So, deep learning is very, very popular. However, we have a lot of things that we need to optimize and all the parameters that we need to do, as for example, when it comes to the architecture, what is the depth, the width, the scales, what kind of modules we will use, what kind of loss function we will use with respect to the problem and the data we have, the optimization strategy that we didn't really talk a lot during this lecture, how we will normalize, we will pre-process the data. And overall, we have a lot of things that we need to optimize. And of course, even if we select about this, it's not like we press a button and everything will work out of the box. We really need to keep track on what is happening on the training and validation curve, what check how the network performs on very few parameters, or how good is on the test and validation set, and how we can actually pre-process the data with the best way for the application. And actually, in at least on the medical challenges, the winning teams are actually the teams that they are spending more time on processing and understanding the data than actually create a novel method with respect to all kinds of other characteristics. So it is very, very important.